Hi, my name is Vishnupriya R and I am studied at Konganadu College of Engineering and Technology. Today, I would like to discuss an important aspect of the Windows operating system, the Windows Environment Subsystem. Windows architecture. Windows 2000 follows a layered architecture, meaning the system is divided into a different layers to enhance the security, stability, and modularity. The two primary layers are user mode and kernel mode. User mode runs application and system processes with limited access to hardware resources. Kernel mode handles the core system operation including the memory management, process control and hardware communications. The modular nature of Windows 2000 means that it builds the using the several independent modules, each responsible for specific functionalities. This structure allows for easier the maintenance, updates and scalability. The futuristic workstation could represent a highly advanced Windows based operating system environment, possible a next generation iteration of Windows OS designed for AI driven computing, cybersecurity, or advanced programming. These models are hardware abstraction layer, kernel, executive services, environment subsystem are key component of the Windows 2000 architecture. Hardware abstraction layer. It is a software layer that sits between the hardware and the operating system. It provides the uniform interface for the OS to interact with the different hardware architecture. It abstracts the details such as interrupt handling, memory access, and processor differences. Kernel. The core of the Windows OS responsible for low-level operations. Manages process scheduling, thread management, exception handling, and synchronization. Works closely with the HAL to provide the access to the system hardware. Next one is executive services, a collection of system services that provides the essential functionalities, manage processes, memory security, input output operations, and object management. Works in kernel mode and communicates with both user mode applications and then kernel. Next one is environment subsystem. Allows the different types of application to run on Windows, supports the Windows applications, process applications and OS by 2 applications. It provides an interface between the user mode applications and then Windows executive services. These models together from the core of Windows 2000 architecture, ensuring the smooth hardware software interactions, resource management, and application support. Modes of Windows operating system. The Windows operating system operation into two main modes. One is kernel mode, another one is user mode. Protected mode or kernel mode. This mode is provides the unrestricted access to system resources including the memory, CPU and external devices. It is used by the operating system core components such as a HAL, kernel, executive services, system drivers and OS level processes run in this mode for high speed privileged executions. Next one is user mode. User application run in this mode with limited access to the system resources. It operates using the collection of subsystems including the Windows subsystem, process subsystem, OS by 2 subsystems. Application in user mode cannot directly access the hardware or system memory. They must request the services from the kernel mode via a system calls. This diagram represents the Windows architecture, showing the layered design of the operating system, which consists of user mode and kernel mode. User mode applications and system services runs in a user mode which has a limited access to system resources. Components in user mode is application. It regular the programs executed by user. Subsystem servers. This provide the additional runtime supports. DLLs. It means the shared libraries used by the applications. System services. It means the essential services that applications uses. Critical services means important background services for the system functionality. The next one is kernel mode. Kernel mode has the direct access to the hardware and system resources. It consists of the several components, several core components. Trap interface or LPC means the handles the communication between the processes and kernel subsystems. Security reference monitor, it means the manages security policies and access control. Input output manager, it means handles the input and output operation between the applications and hardware. Memory management, it means allocates and manages the system memory, processes and threads manager. Manage process scheduling and executions. Device management. Network components, net device and net protocols, net interfaces. It means now manage the network hardware and communications. File and storage management, file filters, file systems, value managers. It means the handle the file access and disk management. File system runtime cache manager. It means they optimize the file storage and access. Next one is device tags. Manage the hardware device through the drivers. Scheduling and synchronization. Scheduler means manage the CPU execution for the processes. Synchronization means ensures smooth executions of multiple threads. System management, object manager or configuration management. It means handles objects like files, processes and the registry. Kernel runtime or HAL. It means the interface with the system hardware. Hardware abstraction layer. Hardware abstraction layer in Windows is a crucial component that provides an interface between the operating system and the physical hardware. What is the HAL? It is the software layer that abstracts the hardware details from the operating system. It ensures that Windows can run on different hardware architecture without requiring modification to the operating system. Why is HAL important? It allows the Windows 2000 and later versions to be the portable across the different hardware platforms. It manages the hardware interaction such as interrupts, timer and power management. HAL provides the consistent API for device drivers, so they don't need to be rewritten for the different hardware. Functions of HAL. Abstractions of CPU and chipsets details. The OS does not need to worry about the specific processor instruction. Next function is interrupt handling. It means that manages how hardware interrupts are proceed. Next one is multiprocessing support. It means helps in managing multiple CPUs in symmetric multiprocessing system. Next function is power management. It means supports sleep, hibernation and other power saving features. This image illustrates the role of the hardware abstraction layer in a distributed real-time computing system, particularly in robotic hardware components. Real-time computing host. These are likely servers or high-performance computing units running applications that interact with robotic hardware. They use the HAL to communicate with different hardware components. Robot hardware components. Various embedded system and robotic components are represented. Each robotic hardware component has an associated HAL layer. It means application to HAL, HAL to hardware flow. Each application interacts with HAL, which in turn communicate with the underlying hardware. The HAL layer abstracts hardware differences, making it easier for applications to be portable across the different robotic components. Why is HAL important in this system? Hardware independence, modularity, scalability. Hardware independent means application does not need to be the rewritten for each different robotic platform. Modularity means the different robotic components can interact with the computing host without the major software changes. Next one is scalability. It means the new hardware can be integrated into the system without modifying application's logic. Next one is kernel. Windows kernel and its relationship with the hardware abstraction layer. Windows kernel features. First one is hybrid kernel. It means the Windows kernel is called a hybrid kernel because it combines the features of monolithic and microkernel architectures. It provides the high performance like a monolithic kernel while maintaining the modularity and separation like microkernel. Integration with HAL. The kernel works closely with the HAL, which abstracts the hardware differences from the operating system. This makes the Windows portable across the different hardware platforms. Next one is CPU scheduling. The kernel manages task scheduling, deciding the which processes get CPU time and with what order. Thi- This ensures efficient resource allocation and multitasking. Processor synchronization. In multi-core processor, the kernel ensures the smooth coordination between the different cores. This helps optimize the performance by balancing workloads among the processor. The three level of kernel mode drivers in Windows. Kernel mode drivers are crucial components of the operating system that interact with the hardware and then system resources. Three levels of kernel mode drivers. First one is the highest level drivers. These drivers don't directly interact with the hardware. They rely on intermediate or low level drivers for hardware communication. Examples: file system drivers, network protocol drivers, intermediate level drivers. These drivers act as a bridge between the high level and low level drivers. They process and route data between the different drivers. Examples: the bus drivers, function drivers, low level drivers. These drivers interact directly with the hardware. They handle the communication with the device at lowest level. Examples: the mini-port devices, hardware abstraction layer drivers. Four main responsibilities of kernel. Main responsibilities of kernel: thread scheduling, interrupt handling, low level processor synchronizations, recovery after a power failure. Thread scheduling means manages the execution of the multiple processes efficiently. Interrupt handling means response to hardware and software interruptions. Low level processor synchronization means ensure the smooth coordination between the processes. Recovery after a power failure means helps the restore systems stability after the unexpected shutdowns. A microkernel is a minimalistic approach to operating system designs where only the essential functions run in the kernel space while other services operates in the user space. This improves the security, stability and flexibility. The key component of this is user space. Device driver management means handles the communication between the hardware and OS. File handling means manages file operations like reading and writing. Protocol stack management, it means manages network communications protocols. Kernel space, process management means controls running applications and their execution. Memory management, it allocates and manages the system memory. Interrupt handling manages the hardware and software interrupts. Execute the privileged instructions. Platform task requiring the full system access. Advantages of microkernel is it more secure as most services run in the user space. Next advantages is more stable since crashes in user space don't affect the kernel. Next one is the easier to modify and extend without the impacting of the core system. Next one is executive services. The executive services is a core part of the operating system that includes the kernel, the HAL. The kernel is manage the system resources and operation. The HAL is provides an interface between the hardware and software. The key function of the executive services is interact with the input output device. It means handles the communication with input and output hardware. Next one is the object management. It manages the OS resources like files, processes and memory objects. Next one is the process management. It schedules and manages the running application. Next one is the system security. It ensures the access control and system protection. Each services is handled by the specific component within the executive services. Components of executive services. First one is object manager. It means manage the system objects. Next one is power manager. It means handles the power management. Next one is the process manager. It manages the system processes. Next one is IO manager. It controls the input output operations. Next one is virtual memory management. It means it manages the memory allocation. Next one is LPC. LPC means a local procedure call. It means enables the communication between the processes. Next one is cache manager. It means speeds up data access. Next one is security reference monitor. It enforces security policies. Next one is plug and play monitor. It detects and manages hardware. Last one is device driver manager. It handles the device drivers. This is Windows XP Executive Services. It provides the services to applications like drawing the GUI, checking security, and handling disk input and output. Depends on the microkernel for all tasks. Microkernel plus executive services together form the Windows XP kernel. Environment subsystem. Environment subsystem, it allows the Windows 2000 to run application made for different operating system. It converts API calls into the format Windows 2000 understands and sends them to the kernel mode. Components of the execution. Main three environment subsystem. Win32 subsystem, OS by 2 subsystem, process subsystem. Win32 subsystem means runs Windows applications and manages the graphical user interface like GUI. OS bar 2 subsystem means it supports the application designed for the OS bar 2 operating system. Process subsystem means it allows the Unix based application to run on Windows. Applications for Windows: web browsers, photo and video editing, document editing, games, communication, productivity, maps and calendar. Web browser is used to browse the internet, examples Chrome, Edge, etc. Photo and video editing, it means edit the image and videos, example the Photoshop, Premiere Pro, etc. Document editing, it create and edit documents, examples the Microsoft Word, etc. Games, play and run video games. Communication, messaging and video calls, examples the Skype, Teams, etc. Productivity, tools for work and organization, examples Excel, Notepad, etc. Maps and calendar, navigation and scheduling, example Google Maps, Outlook calendar. In summary, the Windows environment system plays a crucial role in enabling the Windows to run applications from different operating systems. By supporting the Win32, OS bar 2 and POSIX subsystem, Windows ensure the compatibility and flexibility for various software environments. This subsystem acts as a bridge between the user application and then the Windows kernel, converting the API calls into the format the system can be understand. As a result, the Windows remains a powerful and versatile operating system for users and the developer alike. Thank you for your time.